Today we're going to be introducing some of the very basic elements of digital logic. Digital logic deals with implementing Boolean algebra and logic operations such as AND, OR, and NOT in electric circuits. These operations are implemented with devices, typically transistors, that can abstractly be modeled as switches. Since Boolean algebra uses only two values, true and false, digital logic circuits also focus abstractly on two input and output voltage levels. The values are typically represented by the minimum and maximum allowable voltage in the circuit. Dealing with only two voltage levels, and devices that can abstractly be modeled as switches, makes digital circuits relatively easy to work with and design compared to their analog counterparts. The fact that digital logic circuits are primarily concerned only with whether a value is low or high also makes them robust and noise tolerant, because even if a signal is not exactly at the ideal true or false level, it will generally be much closer to one of the two values and can be interpreted as that value. Logic operations are implemented digitally in the form of logic gates. For example, a digital AND gate implements the logical AND operation. There are many different ways to internally create a given logic gate. For example, TTL, or transistor-transistor logic, implements an operation using BJTs and resistors, while CMOS logic, or complementary metal oxide semiconductor logic, implements operations using P and N-type MOSFETs. These and other logic styles can each implement all logic operation. Each logic style has different speed, size, and power characteristics. As an example of a few different logic styles, here we show the NAND, not AND operation for transistor-transistor logic, NMOS logic, and CMOS logic. CMOS logic on the right is the current dominant technology due to its low power consumption and small size. Boolean algebra deals with variables that can only have one of two values, true or false, also represented as 1 and 0 respectively. In digital logic implementations of logic operations, false or 0 and true or 1 serve as abstractions of the actual voltage level that is used to represent the logic value. Generally speaking, logic 0 is represented by 0 volts. Logic 1 is typically represented by the maximum voltage of the circuit, generally referred to as VDD or VCC. Example values of VDD include 5, 3.3, and 2.5 volts for discrete logic chips. The latest integrated logic technologies use voltages of a volt or less. As we will discuss in the future, these lower voltages result in faster switching and lower power consumption. When it comes to representing logic operations, there are multiple options available. Truth tables explicitly list all possible input combinations and the associated output value for each input combination. Logic equations make use of Boolean algebra to express the logic operation. And finally, one or more logic gate symbols can be combined and connected to show the operation. You will have an opportunity to refresh your memory of these different options following the video.